This video is just quickly going to go through food webs and hopefully explain some of the points that might be difficult. So last week we looked at sampling biotic factors, so biotic factors being ones that are caused by living organisms. This week we look at food webs, and we'll start with a little bit of a recap on food chains. And next week we'll probably go on to look at the impact things can have on food chains. By the end of this lesson, you should learn how living things can impact each other and be able to identify producers and consumers in food chains, understand how several food chains can combine to make a food web, and explain the impact of adding and removing species from a food web. This is just a slightly blurry recap of food chains. You should have done this in S1. So you should know that all energy that we have in an ecosystem comes initially from the sun. So the sun emits a wide spectrum of radiation. Part of the radiation the sun emits is light energy, which is picked up by producers. So producers of these green plants are always the start of a food chain. In a food chain, we don't include this first little section here, so you wouldn't have the sun and this arrow. It's just to demonstrate, to start off with, where the energy comes from. So your food chain would start with the producer, which is the green plant, and it takes the energy from the sun. We can then see there's an arrow going to the next organism, which is a rabbit. So we probably intuitively understand that that rabbit has eaten that plant. So a lot of people wonder, well, why isn't the arrow going the other way? That would show what eats what. But these arrows in a food chain, they show the movement of energy through the ecosystem. So the energy from the sun has gotten to the green plant, which goes to the rabbit. If the rabbit is eaten by this eagle, then the energy will move that way. So these arrows show the movement of energy through an ecosystem, and this is quite a nice simple way to draw it out. This is a food chain because it shows only one pathway of the energy. In this diagram, it looks like only the rabbit will eat that grass, but we know, obviously, that if this is grass, there might be sheep or cows or horses or lots of other herbivores which might eat that grass. This is just one simple way of looking at it. So we had the producer, and everything after that we will call the consumer, because it is required to eat something or consume something in order to gain its energy. We can build those together. You can see it's a lot more complex into something called a food web. A food web is made up of all the different food chains within that ecosystem. So if we try and find the producer here, it's a lot more tricky. Now, this example isn't set out in the way we tend to do it in Scotland. We would always tend to put the producer in a food web at the bottom, and then the first set of consumers, what we call the primary consumers, in the next row, and the next row we would have secondary consumers, tertiary consumers, quaternary consumers, all the way up, as far as you need to go. So in this example, phytoplankton, if you follow all the arrows backwards, the energy seems to come from phytoplanktons and algae, I believe. So the difference between this and a food chain is obviously that if we take algae as an example, algae's energy goes to limpets. At the moment, it's just one arrow, so it's like a food chain. But from limpets, their energy is split towards octopi and starfish. So the energy that the algae has generated from the sun goes to limpets and then is split to octopi and starfish. Their energy goes to the shark and to just the shark. It looks like starfish also get their energy from mussels. Mussels get their energy from, if we follow this backwards, phytoplankton. So those are the two producers. And follow up. You can see how this is slightly more confusing than if we layered everything out nicely. So this is a question you quite often get in some of the more tricky exams, where they will give you a list of consumers and food, and you have to work out what from this list is the producer and what from this list are the consumers, and you can then build a really, really complicated food web out of this. If we follow it backwards, you're looking for an organism that is essentially not on the left. That's how we find our producers, because they don't need to consume something. If you do that, you'll find that algae and pondweed are found nowhere on the left-hand side. They must be our two producers in this example. So we would put algae down as our producer, and then we'd look to see what on the left needs to eat algae. So if we walk down a list, if algae were here as our producer, one of our primary consumers would be a water flea, another one would be a caddisfly larvae, another one would be a snail. This algae's doing a lot of good work. And if we follow it down, nothing else seems to eat algae. On the other side, pondweed, we would say, okay, we don't need water flea, but we would have an arrow to caddisfly larvae, to snail. We would have an arrow to tadpoles, and then you would work up. We've got water fleas above algae. What eats water fleas? Sticklebacks. So you put sticklebacks above, and you draw an arrow from water flea to sticklebacks. So if we do this, putting our producers in, putting the primary consumers in, putting secondary consumers in, what are called tertiary consumers, and then we draw the arrows showing where the energy is going in this ecosystem, slowly building over time. I like to do this digitally, so on a computer, because it means that if I accidentally put snail here and it's all getting a little bit kind of busy, I can move it and move all the arrows. So if you draw this on paper, you sometimes end up with a situation where you've accidentally put all of the primary consumers at one end of the page. So that, I believe, is the full ecosystem. So this food web goes from pondweed. You can follow any of the food chains within this food web. So if we start with pondweed and we want to get to pike, we can go caddisfly fly larvae to water beetle to perch to pike, or we can go tadpole to water beetle to perch to pike, or tadpole to perch to pike, skipping water beetle. So you can see you can follow this energy around. What it allows us to do is work out which other organisms would be affected if we increase or decrease the number of these organisms. People who do professional pest control, for example, would work out what the food chain within that area was and work out, well, if I take the spiders, or if I take the bees, or if I take the rats out of this food web, what's going to happen to everything else? So you can build a food web now. Grass is eaten by rabbits and voles, so I would like you to just pause the video and have a go at that. Dandelions eaten by snails, voles, and rabbits. Weasels eaten by voles. Thrushes eaten by snails. And foxes eaten by rabbits, voles, thrushes, and weasels. It might look something like this. What's quite good about a food web, as I've said, is it allows us to work out what other organisms will be affected if we remove one or add one. So, for example, if we were to remove the dandelions, what other organisms are going to be affected? So if we just scan across, this green plant here, we will assume is grass, doesn't really seem to be affected so far. This rabbit, is it affected? Well, it looks like it was getting energy from both the grass and the dandelion. So the rabbits that were mostly eating dandelions, they're going to have to switch to eating more grass. Now, initially, that means more grass is going to be eaten. So probably the amount of grass in your ecosystem is going to decrease because suddenly the rabbits don't have two different food sources. They only have the one food source. So all of them have to get their entire energy requirement from grass. And actually, they're not the only ones in the ecosystem. There's this rat here. Now, they also were getting their energy from the grass and from the dandelions. So they also need to switch all of their energy requirements towards the grass. So the rabbits are eating twice as much grass. The rats are eating twice as much grass. The grass is going to massively decrease in number. And then when all the grass is gone, what are the rabbits and the rats going to eat? Probably absolutely nothing. So